Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing definite integrals. Let's see this. Type 1, algebraic. We're going to do algebraic function. Integral of 6x squared minus 4x minus 5 with respect to x when the limits are between 0 to 3. Now this is identical to your indefinite integrals except that they have given you the limits. You solve it exactly like your indefinite integral, only one step has to be extra in this. Let's see this. For the timing, assume that this is not there. Let's try to solve it like your indefinite integral. This is going to be 6 integral of 0 to 3 x square dx minus 4 integral of 0 to 3 x dx minus 5 integral of 0 to 3 dx. What did I do? I opened the brackets, right? 6 integral of x square. You will be using the formula integral of x raised to n. Integral of x raised to n is n plus 1 upon n plus 1. So 2 plus 1 upon 2 plus 1 when the limits are between 0 to 3. X means x raised to 1. Same formula again. Integral of x raised to n is n plus 1 upon n plus 1 when the limits are between 0 to 3. Minus 5. Integral of dx is x when the limits are between 0 to 3. Right? So this is 6 upon 3 x cube when the limits are between 0 to 3. 4 upon 2 x square when the limits are between 0 to 3. And 5x when the limits are between 0 to 3. 3 1s are, 3 2s are, 2 1s are, 2 2s are. 2. Now how do I solve the limits? Substitute the value of x with upper limit and then with lower limit. It is upper limit minus the lower limit. Upper limit is 3. So this will be 3 cube minus 0 cube. It is upper limit minus lower limit. Substitute the variable first with upper limit, subtract it with the lower limit. Minus 2 upper limit minus lower limit minus 5 upper limit minus lower limit. One more thing that you have to remember here is that in definite integrals you will not have a plus c. When we were doing indefinite integrals we always used to end with plus c. Here you don't do that. 3 cube is 27 minus 2 3 square is 9 minus 15. So this is going to be 54 minus 18 minus 15. You can solve this and get your answer. Your answer should be equal to 21. Right? Let's take on the next one please. Integral of 0 to 1 x cube minus 2x square plus 3 upon root x dx. Now this can be written as integral of 0 to 1 as it is. This can be written as x cube upon root x minus 2x square upon root x plus 3 upon root x dx. What did I do here? I just split the numerator. This can be written as 0 to 1. X cube is nothing but x square into x. See guys, x cube is nothing but x square into x. X can be written as root x into root x. So that means x cube can be written as x square root x into root x. There is a root x in the denominator which will cancel. So you will get this as x square root x minus 2. This is going to give you x root x plus 3 root x. 3 upon root x. Okay, we'll do the conversion in the next step. Now root x guys can be written as raised to 1 by 2. So this is x square root x is x raised to 3 by 2 minus 2 plus 1 by 2, 5 by 2. X root x is x raised to 3 by 2 minus plus x raised to minus 1 by 2 dx I have converted all the root x to raised to 1 by 2. Right? Now, this can be written as integral of 0 to 1 x raised to 5 by 2 dx minus 2 integral of 0 to 1 x raised to 3 by 2 dx plus 3 integral of 0 to 1 x raised to minus 1 by 2 dx. This can be written as x raised to 5 by 2 plus 1, that's 7 by 2 upon 7 by 2. Guys, everyone's understood what formula did I use? I used the formula integral of x raised to n plus 1 upon n plus 1, x raised to n plus 1 upon n plus 1, minus 2, okay wait, when the limits are between 0 to 1, minus 2, 3 by 2 plus 1 is 5 by 2 upon 5 by 2, when the limits are 0 to 1, plus 3 x raised to minus 1 by 2 plus 1 is plus 1 by 2 upon 1 by 2 when the limits are between 0 to 1. Denominator of denominator becomes numerator. So 2 raised to 7. This is x raised to 7 by 2 when the limits are 0 to 1. 2 2s are 4 upon 5 x raised to 5 by 2 when the limits are between 0 to 1. Plus 6 x raised to 1 by 2 when the limits are between 0 to 1. How do you solve the limits? Substitute with upper limit minus lower limit. So this is going to be 2 by 7, 1 raised to 7 by 2 minus 0 raised to 7 by 2, minus 4 by 5, 1 raised to 5 by 2 minus 0 raised to 5 by 2, plus 6, 1 raised to 1 by 2 minus 0 raised to 1 by 2. So this is 2 by 7. 1 raised to anything is 1, multiplied by 2 by 7 will give you 2 by 7 only, minus 4 by 5 plus 6, 7 5s are 35, 35 will be your common denominator. So in that case 5 2s are 10, 7 4s are 28, and this is going to be 35 into 6, that is going to be 210. So when you solve this, you will get this answer as 192 upon 35. Fine. Let's move on to the next one, guys. Integral of 0 to 1 dx upon root of x plus 3 minus root of x plus 1 dx. Rationalize the denominator. This can be written as integral of 0 to 1 dx root of x plus 3 minus root of x plus 1. If I rationalize this will be root of x plus 3 plus root of x plus 1 upon root of x plus 3 plus root of x plus 1. I will write the dx at the end. This is integral of 0 to 1. The numerator will be root of x plus 3 plus root of x plus 1. In the denominator you have a minus b, a plus b. A minus b, a plus b is a square minus b square. Everyone's understood this? It would have been root x plus 3 the whole square. So the square and root gets cancelled. That's how I got x plus 3 minus x plus 1 dx. This is 0 to 1 root of x plus 3 plus root of x plus 1 upon x plus 3 minus x minus 1 dx. Plus x minus x gets cancelled. So this is going to be 3 minus 1, 2. Constants come outside the integral sign. 0 to 1. Split the integral. So that will be root of x plus 3 dx plus integral of 0 to 1 root of x plus 1 dx. Right? This can be written as 1 by 2 integral of 0 to 1 x plus 3 raised to 1 by 2 dx plus 0 to 1 x plus 1 raised to 1 by 2 dx. 1 by 2. Integral of ax plus b raised to n. Integral of ax plus b raised to n is 1 upon ax plus b raised to n plus 1 upon n plus 1. That formula I need to use. A is the number with x, which is 1 here. So in that case, this is going to be equal to x plus 3. 1 by 2 plus 1 is 3 by 2 upon 3 by 2. When the limits are between 0 to 1, plus x plus 1. 1 by 2 plus 1, 3 by 2 upon 3 by 2 when the limits are between 0 to 1. Right? This can be written as 1 by 2, 2 by 3. Substitute the value of x with upper limit minus lower limit. So this is 1 plus 3 raised to 3 by 2 minus 0 plus 3 raised to 3 by 2. Upper limit minus lower limit. Substitute the value of x with upper limit and then with lower limit. Plus 2 by 3. Upper limit minus lower limit. So this is going to be 1 plus 1 raised to 3 by 2 minus 0 plus 1 raised to 3 by 2. Right? So in that case, this will give you 1 upon 2, 2 by 3. This is going to be 4 raised to 3 by 2 minus 3 raised to 3 by 2 plus 2 by 3, 2 raised to 3 by 2 minus 1 raised to 3 by 2. 2 by 3 comes out, so 1 by 2 into 2 by 3 common I am removing outside. 4 can be written as 2 square raised to 3 by 2 minus 3 raised to 3 by 2 plus 2 raised to 3 by 2 minus 1 square, and this 2 gets cancelled. So this is going to give you this 2 and this 2 also gets cancelled. This is 1 by 3, 2 cube 8 minus 3 cube 27. Root of 27 is nothing but 3 root 3 plus 2 cube is 8. Root of 8 is 2 root 2 minus 1. That will be your answer. Fine, we get this thing here. Next, let's see another sum, guys. We could simplify this further to get 8 minus 1, that's 7. So 7 minus 3 root 3 plus 2 root 2. Right, let's see another sum, guys. Integral of dx upon root of x plus 3. Right, now this can be written as integral of the limits are between 0 to 1. 0 to 1. This is going to be x plus 3 raised to minus 1 by 2 dx. Root can be written as 1 by 2. When I bring from denominator to numerator, the sign of the indice changes. Right? Now this is going to be equal to
dx root x plus 3 dx.
This is going to be equal to x raised to x plus 3 minus 1 by 2 plus 1. That's 1 by 2 upon 1 by 2 when the limits are between 0 to 1. This can be written as 2, 1 plus 3 raised to 1 by 2 minus 0 plus 3 raised to 1 by 2.
So won't it be 1 upon 3?
Why will it be 1?
No, I mean 1 upon a, that formula.
So what is the value of a here? A is the number with x. What is the number with x? 1. So this is 2. This is 4 raised to 1 by 2 minus 3 raised to 1 by 2. So 2. This is 2 square raised to 1 by 2 minus root 3. So your answer is 2 minus root 3. Fine, do we get this thing here? This finishes algebraic integration, definite integrals. We will stop this here for the day. Thank you very much.